Assalamualaikum warahmatullahi wabarakatuh. My name is Rosina Laili binti Muhammad Yusuf. This is our presentation about experiment 3, which is friction losses in pipe. So this is our introduction for the experiment. For the problem statement, there will be several issues that will arise during this experiment. We need to figure out how much the major losses are worth. If we don't know how much they are worth, we will not able to move on to the next step. The heat loss in a length of tubing is measured as a function of discharge. In this experiment, pressure sensor will be used to measure heat loss in small diameter plastic pipe. So the objective of this experiment is to determine the pipe major, minor and friction losses, as well as the complete fluid flow measurement technique. The second one is to investigate the amount of velocity for various types of pipe with various diameter. And the last one for the scope is the first one is to determine whether a laminar or turbulent flow will occur during the experiment, and the second one is to investigate the effect of different pipe diameter on velocity. The friction factor will be linked to the range of the flow rate.
Okay, hi, my name is Muhammad Farhan Hakim bin Razab. So today I will explain about the theory of our projects, which is, let's go first for introduction. This chapter is to show the mathematical equations or theoretical background of the experiment. So for the theory, fluid friction occurs between fluid layers that are moving relative to each other. This internal resistance to flow is named viscosity or viscous drag of fluid friction. In normal terms, the viscosity in a fluid is described as the thickness of the fluid. Thus, water is thin, having a lower viscosity, while honey is thick, having a higher viscosity. The less viscous in the fluid, the greater it is in deformation or movement. So, there are following the two types of force between the molecules, which is cohesive force. So cohesive force are attractive force that exist between molecules of the same substance. So cohesive force are the main cause of viscosity actually. And the second one is adhesive force. They are attractive force between unlike molecules. So an object traversing a fluid loses its energy in order to overcome the fluid friction. The shape of an object plays an important role in increasing and decreasing the fluid friction when it travels along with it. So right here we can see the type of object traversing fluid loses its energy. So let's go for loss of fluid frictions. The law of fluid frictions are, first law is the fluid friction increases with an increase in the area of contact between the surface and the fluid. Second law, the fluid friction increase with an increase in the velocity gradient and the substance. And the third law is the fluid having a higher coefficient of fluid friction or ETA has a higher value of fluid friction force. So this is a derivation for fluid fraction formula, and this is the figure 2 for fluid friction. And next we go factors affecting fluid friction, which is the first one is nature of fluid, and the second one is the viscosity of fluid, and the third one the shape of the body, the fourth is the temperature, five is the surface area of the body, and six is speed of the body, and the last one is the pressure of the body. So there are some type of synonyms in fluid friction, which is viscous resistance, friction and force in fluid, fluid friction, force of fluid friction, drag in fluid, fluid inertia. And a few examples that can show resistance of fluid is a resistance experienced by swimmer in the water, and also lubricant can relieve friction between the two solid surface due to fluid friction. Lubrication can be seen in door hinges, machine parts, and also lubricant friction can be considered as an example of fluid friction. And also this is friction in the water in the river, water moving in pipelines, also the flow in the honey from the bottle. So for the literature review, we decided to take this from this website because it's explained the definition of this process, and for the calculations, we refer to this website. So I think that's all from me. Thank you so much.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Tuan Muhammad Izzat bin Tuan Muhammad Fauzi. My metric number MA19257. I'm from section 02 and I'm from group 6. So now I will explain about 3.0 method. An experiment was carried out in order to achieve the experiment's objectives. The objective of this experiment was to observe and comprehend the nature of a frictional flow of a fluid in a pipe and the relationship with the fluid's Reynolds number. Overall, heat loss in a pipe is affected by a number of factors, which include the viscosity of the fluid, the size of the internal pipe diameter, the internal roughness of the inner surface of the pipe, the change in elevation between the ends of the pipe, and the length of the pipe along which the fluid travels. Next, for the apparatus for experiment 1 and 2, major losses, straight pipe, and minor losses. First, fluid friction apparatus include valve, control valve, and pump. Next, hydraulic bench. Next, pressure sensor, flow rate indicator, and lastly, data measurement and acquisition. This three figure shows figure 1 fluid friction apparatus, next figure 2 pressure sensor, and lastly figure 3 flow rate indicator. The procedure for experiment 1, which is major losses in straight pipe. First, all the valves were opened by turning it to the left. Next, the pump was turned on by pushing the switch on button. Next, control valve was rotated to adjust the volume of water flow. Next step, unused valves were closed by turning it to the right, only use straight pipe. Next step, two pressure sensors were taken and connected to the pressure sensor connection point at the pipes that have water flow to measure pressure in the pipes. And lastly, flow rate indicator wires will be connected to the pressure sensor to get the measurement of flow rate in the pipe. For procedure for experiment 2, minor losses, first all the valves were opened by turning to the left. The pump was turned on by pushing the switch on button. Control valve was rotated to adjust the volume of water flow. Unused valves were closed by turning it to the right. Only use 90 degree of elbow pipe, 90 and 45 degree of bend pipe. Next, two pressure sensors were taken and connected to the pressure sensor connection point at the pipe that has water flow to measure pressure in the pipes. And lastly, flow rate indicator was connected to the pressure sensor to get measurement of flow rate in the pipes.
Assalamualaikum, my name is Muhammad Kanu Imran bin Ahmad Suhaimi and my matrix number is MA19223 and my section is 02. Today I'm going to explain about experiment 1, major losses in straight pipes. This experiment is required to find and calculate these data. Based on the graph, we can see the huge difference between calculated head loss and measured head loss. However, these values are increased along with the flow speed. Therefore, the head loss in pipe are directly proportional to the flow speed. Meanwhile, there are different cases in pipe friction coefficient. Based on the graph, we can see the value of head loss is inversely proportional to flow speed, which the value of head loss is increasing, but the value of pipe friction coefficient is decreasing.
Hello and very good morning. My name is Natasha Akun. My matrix ID is MA18029. So today I will be presenting to you about the results and discussions for experiment 2. So for the elbow pipe, the answers has been tabulated in the following table, in which these are the sample calculations. And as for the 90-degree bend pipe, the following has been calculated and also tabulated in the following table. And these are the sample calculations. Same goes for the 45-degree bend pipe. Okay, so for the graph and discussions for experiment 2, for the elbow pipe, as you can see from the graph, we can observe that the value of measured and calculated loss coefficient decreases as the velocity of the water decreases in elbow pipe. So the head loss is directly proportional to the velocity of water in the elbow pipe. For the measured head loss and calculated loss coefficient against Reynolds number, from the graph above, you can observe that the measured head loss and calculated loss coefficient decreases as the Reynolds number increases. So we can conclude that the calculated loss coefficient depends on the roughness and diameter of the pipe. As for the 90-degree bend pipe, for the measured head loss and pipe coefficient against velocity, from the graph, you can observe that the value of measured head loss and pipe friction coefficient increase as the velocity of the water increases. So we can conclude that the head loss is directly proportional to the velocity of the water in the 90-degree bend pipe. As for the loss coefficient and equivalent length against Reynolds number, from the above graph, we can observe that the loss coefficient K and equivalent length LE decrease as the Reynolds number increases. So the loss coefficient mainly depends on the roughness and diameter of the pipe. And for the 5-degree bend pipe, for the measure head loss and pipe friction coefficient against velocity, so the curve shown is affected by the data and thus the curve does not get as expected except for measured head loss. So the difference between those two is that measured head loss tends to form a constant line and does not continue to further create another gradient like calculated head loss from a decreased gradient. For the loss coefficient and equivalent length against Reynolds number, from the graph above we can observe that the loss coefficient and equivalent length LA decrease as the Reynolds number increases. So the loss coefficient depends on the roughness and diameter of the pipe. So that is all from me. Thank you.
Hello, my name is Puteri No Ainu Sofa binti Kamaru Isham. My metric number is MA19251. So I want to talk about conclusion. So the conclusion is we can conclude that our experiment was successful, and this experiment is to demonstrate the nature of the frictional flow of a fluid in a pipe and the relationship with the fluid's Reynolds number. So in fluid flow, the major head loss is the loss of pressure in the pipe flow due to the effect of the fluid's viscosity near the surface of the pipe. So the minor variation in this lab has suggested the importance of fluid flow in a pipe of circular regimen. This has helped in understanding fluid behavior and change in developing velocity profiles. So this experiment has proved that the concept of studies and relationship between various parameters in terms of proportional and theoretical versus practical data. So by improving better observation and consistency, there could be more understanding of the concept. However, the objective of the experiment are attained and predictions to compare with experimental data. That's all. Thank you.